study session before the second test. But tonight we're going to look at any questions you may have from chapter 19 and the practice test.
The test only covers chapter 19. Are we going over 18 as well?
You're breaking up. What was the question?
Are we going over chapter 18, or does the test not cover chapter 18?
We did chapter 18 in the last the study session last week.
So we're no longer doing it?
So we did chapter 18 last week. So tonight the focus is chapter 19. But if we have time, we can revisit any questions that you may have. But the test is on both chapters.
Can we do the questions from the study guide from the practice test, because the questions that we did that are used within the chapters don't really, they have the same wording, but the use of the equations, I can't, me personally, I can't figure out which equation matches up with which.
Which one?
For a good amount of the practice test.
You cannot identify which equations to use. Is that what you say?
Well, I can identify, like I can see the different specific variables that are associated with each one. But when it comes to selecting it, like I'll go through the problem and work out the problem with the equation, but I won't get any of the answers that are within the answer choice. So I just wanted to make sure that I was doing it correctly. And I personally don't think that any of the like a select few of the problems that are on the practice test have any resemblance to the wording of the problems that were in the book.
Well, that's strange because there is a strong correlation.
Yeah, like if any way possible, can we can we go through like how we did for the last practice test, and you explain how we get to those answers?
Okay, so let's take a vote. How many people think we should start with the practice test and then go to chapter 19, or vice versa?
Let's start with the practice test.
You start with the practice test.
Practice test.
Okay, so the class decision is unanimous. So we'll start with the practice test. Okay, and then whatever time we have left, we will look at chapter 19. Okay. So we'll try to go as fast as we can because I have a second session with the other class. So let me close this whiteboard and instead share the okay. So number one, could somebody read number one?
Doug rubs a piece of fur on a hard rubber rod, giving the rod a negative charge. What happens?
Okay, so what happens? We have four choices. Which of the choices is correct and why? I'm more interested in why.
Well, because when the fur is rubbed on the rod, the fur basically takes away the electron. So it's more the electrons are more attracted to the fur.
So you say the answer is what?
I say it's A.
You say protons are removed from the rod.
Yeah.
Okay, does everyone agree?
Yep.
Okay. So A is not correct. Okay, the correct answer is B, and the reason is that charging takes place by transfer of electrons. Okay, if you read chapter 18, which talks about the concept of charge, charge transfer takes place through electrons. So basically what we're saying is that protons do not move from one object to the other.
Okay.
Okay, and does anyone understand why?
No, go ahead.
Okay, if we look at the structure of the atom, where are protons located?
Protons are located within the atom, within the central part of the atom.
Yeah, they're located in the nucleus. So it takes a lot of energy to pull away a proton. You have to go right inside the nucleus of the atom to pull away protons. Then I want to write electrons. Electrons. Okay. Number 2. Now, before we go to number 2, what we're saying here is that if an object has a positive charge, it means it has lost electrons. If an object acquires a negative charge, it means it has received electrons from another object. Does that make sense?
Mm-hmm.
So positive charge does not mean you've gained protons. Negative charge doesn't mean you lost protons because charge transfer takes place by electrons only. Okay, number 2.
A metallic object carries a charge of negative 3.0 times 10 to the negative 6 coulombs. What total number of electrons does this represent?
Okay, so this is a unit conversion problem. Okay, there is noise from somebody's line. If the noise is coming from your line, please reduce the noise around you. Now, number 2 is a unit conversion problem. And so we have minus 3 times 10 to the minus 6 coulombs of charge. And we want to convert this to what?
Electrons.
Electrons. What is the conversion factor?
It's 1.6 times 10 to the negative 19 coulombs.
Okay, so one electron is equal to 1.6, actually minus 1.6 times 10 to the minus 19 coulombs. So you would write your conversion factor so that the coulombs go in the denominator. So minus 1.6 goes here and then 1 electron there. So this way the coulombs cancel out. And if you divide, what do you get? 1.6, 3 divided by 1.6. Okay, what is the answer?
Um, hold on just a second.
Okay, I need everyone to be active, to be interactive in this session.
I got 1 point. It would be rounded off to 1.9 times 10 to the 13.
Okay, and that is C, right?
Mm-hmm.
Okay, so that's number 2. Number 3. Okay, Quentin, can you read number 3?
2-point charges are 15 centimeters apart. They are moving to a new separation of 3 centimeters. By what factor does the resulting mutual force between them change?
Okay, so how the force between two charges depends on which parameters?
Wait.
Q1 and Q2. What was your question?
Yeah.
The force between two charges is given by,
Coulomb.
okay, what is Coulomb's law?
That's
K, and then times Q1, Q2 over R squared.
Okay, so from this law, we learned that the force is proportional to 1 over R squared.
Right.
Okay,
you
does that make sense?
said that it's proportional or inversely proportional.
It's proportional to 1 over R squared, or
Okay.
you could say it's inversely proportional to R squared.
Okay.
Okay, so it's inversely proportional to R squared, or it changes as a function of 1 over R squared. So what does this mean? So if you double, let's say double R, what happens to F?
It decreases R.
F, does it increase or decrease?
Increases.
Somebody is saying increases, another person is saying decreases.
It decreases.
Decreases.
Okay, so when you increase the denominator of a fraction, the overall fraction decreases, right?
Yeah.
So basically, you're dividing by a bigger number, you're going to end up with a smaller number. Okay, so F will, if you double R, then F will decrease by what factor?
4.
By 4. So F will decrease by 1 over 4. Okay? Well, because you have 1 over R squared. Now, if you look at this problem, the separation was 15, and then the new separation is 3. So what is happening to the separation?
It's decreasing.
Okay, so it's decreasing by what factor?
Decreasing by 5. Wait. No.
It decreased by a factor of 5, right?
Right.
Okay, so what that means F will, what will F do if it decrease the separation?
It is going to increase.
It's going to increase. Okay, so F will increase by what?
How did it decrease by 5?
If you go from 15 to 3, what ratio is that? How many times is 15 bigger than 3?
5.
5 times. So 15 over 3 is 5. 3 over 15 is 1 over 5. So either way, the ratio is 5. So if you go from 15, separation of 15 to a separation of 3, that means you've decreased the separation by a factor of 5. So based on this inverse proportionality, if the separation decreases, then f will increase. But f will increase by the square of the factor by which you change r. So f will increase by 25.
And how did you get 25?
Okay, can somebody explain how we got 25?
So basically, what you do is that now that we know that it decreases, like R decreases by 5. So if you were to put it in the problem at the top, that's in the red, where it says F is proportional to 1 over R squared. If you put 5 in, you get 1 over 25. So
Well, that is a little bit misleading because the answer is 25. So what you're explaining seems to suggest that the answer is 1 over 25, but the answer is not 1 over 25.
I'm still lost.
Okay, now let me take it all over again. So decreasing by 5 actually means the factor of change is 1 over 5, right?
mhm.
Because 15, the original separation divided by the new separation is 1 over 5. Okay? So if you do 1 divided by 1 over 5 squared, you get 25.
Like that, but you just said 1 over 5 squared.
Yeah, so the separation changed by 15 over 3, which is 1 over 5. And f depends on 1 over r squared. Okay? So take this 1 over 5 and plug into the place of r. You will get 1 divided by 1 over 5 squared, which is 25 over 1.
So if we were given a problem, another problem like this, is best to take the ratio of it, like you did right there, and then plug it back into 1 over R squared, and you get.
Yeah, you could do that, or you could just argue the way we argued here. You know that if r decreases, f should be bigger. So the answer cannot be 1 over 25, because if it's 1 over 25, that you're saying that the force is smaller. Does that make sense?
Yeah.
If your answer was 1 over 25, if the new force is 1 over 25, then you're saying the new force is smaller than the original force, which is wrong, because the new force should be bigger because you have a smaller r. A smaller r means a bigger f. Okay?
Okay.
All right. So A could not be correct because there is a square in the R. B could not be correct because, again, there is a square. And E is completely wrong. So the only 2 possible answers were C and D. But C has been eliminated because C implies that the new force is smaller. So that's another way you could answer the problem, by elimination. Now, let's quickly go to number 4.
If the distance between 2 point charges is doubled, the mutual force between them will be changed by what factor?
Okay, so again, F is inversely proportional to R squared. So if you double R, what happens to F?
It decreases.
Double R, then F decreases by what factor?
4.
1 4.
1 over 4. Okay? Does that make sense?
No, can you explain that one?
If you double, so if you double R, that means you put a 2 in here.
Okay.
Then your new force will be F, or 1 over 4R squared, right? That, which is the same as 1 over 4 times 1 over R squared. So the factor is 1 over 4. Does that make sense? Any questions? No? Okay. If there are no questions, let's proceed. But these three problems are based on Coulomb's law. Okay, so you have to understand that in Coulomb's law, the force is proportional to the charge Q1, the force is proportional to the charge Q2, but the force is inversely proportional to R squared. That means if Q1 or Q2 increases, then F will increase by the same amount. But with R, when R increases, then F decreases, and it decreases by 1 over the square of the factor. Now, if R decreases, then F will increase, again, by the square of 1 over the factor. Okay? Okay, number 5. So number 5 is still in this class of problems. So F is equal to K Q1 Q2 over R squared. Taylor, can you read number 5?
The size of the charge value is double for both 2-point charges maintained at a constant separation. The mutual force between them will be changed by what factor?
Okay. So the value of the charge is double for how many?
2-point charge.
For both of the point charges. That means the charge on Q1 is doubled and the charge on Q2 is also doubled, right? Does that make sense?
Mm-hmm.
So that means you have a factor of 2 here. You have a factor of 2 there. So that gives us a factor of what?
4.
4. So the F will increase by 4. And that is because F is directly proportional to Q1. F is also directly proportional to Q2. So if you double Q1, F increases by 2. You double Q2, F increases again by 2, which gives you 4. Okay?
So what if it says that it was triple?
Yeah, so if both were triple, 3 times 3 will be what?
6.
No?
Oh, wait, 9.
9.
So the change, the 9 will be the factor?
Yeah, the answer will be 9.
Oh, okay. Number 6.
Okay? Number 6. Someone read number 6.
I can't see the whole question.
You cannot see the question on the screen.
A charge of C, no. A charge of 2, C is at the organ. When charge Q is placed at 2 along the positive x-axis, does it say the M along the negative x-axis becomes 0? What is the value of Q?
Okay, the field at 2 meters, 2 meters along the negative x-axis. So the 2 and m are together. That's 2 meters. So what they're saying is the electric field here at this point is 0. So they wanted to solve for the value of Q. Okay. Are we on the same page?
Not really.
Okay, a charge of +2 is placed at the origin. So this is the origin right here,
Right when?
right here.
Okay.
Okay. Now then, when a charge Q is placed 2 meters along the positive x-axis, that's here, 2 meters from the origin is here. The electric field at 2 meters along the negative x-axis, 2 meters along the negative x-axis is here. So the electric field at this point is 0. What is the value of Q? So they want us to find the value of Q that when combined with the 2 Coulomb charge will give you a net electric field of 0 at the x, at the point x. Does anyone know how to approach this problem?
It'll be C times C.
Say it again.
We can do C times C.
2 times what?
Would you take in consideration that it's a +2? The charge at the origin is +2, so you would see which way that the electric field would go,
Okay.
either it be towards or away.
Okay, so at this point, the point marked x, the electric field from the +2 Coulomb charge is in which direction?
It would be away.
Away means what?
Left.
Okay, away means to the left. So let's call this charge number 1, and let's call this charge number 2. So this will be E1. So in which direction will the other electric field have to be for the electric field at this point to be 0?
It would have to go to the right.
You will have to go to the right. That means the charge Q must be which kind of charge?
Charge Q.
Negative.
Yeah.
It must be a negative charge because electric field points towards negative charge. Does that make sense? Okay. So that's the first step. Now, for the so the electric field in this at this point, E2 minus E1 is equal to 0. That's what the problem says. So that means E2 must equal E1, but they have to be in opposite directions. Now, what is the formula for E?
Negative. K times Q over R squared.
Okay, so K. So K times Q2 over R2 squared equals K times Q1 over R1 squared. Okay? So the K's cancel out. So the K's will cancel out. Okay, and then you can solve for Q2. Q2 equals Q1 over R1 squared times R2.
Tom, can you move this box? Because I can't see the rest of the equation.
Well, this is visible on the screen. It's just, are you using a tablet?
No.
Yeah, this is right within the
I'm
screen.
saying, like, I see, like, Taylor, Quentin, Moses, Imani. I see that. That's covering my problem. I can't. Wait. Oh, wait. Okay, never mind. Go ahead. I had to move it.
Okay, so this is basically what you have to do. Your Q1 is 2 coulombs. Your R1 is what? What is R1?
+2.
No, R1 is the distance from charge number 1 to the field point. What is that?
2.
2 meters. What is R2?
2 meters.
No.
Not.
R2 is the distance of charge number 2 to the field point. This is R2.
Oh, okay.
Okay,
So
what is that?
Maybe 4.
that'd be 4.
Yeah, that's 4.
Yeah.
So you have to pay attention. R2, R in this equation refers to the distance of the charge in the problem to the point where you're calculating the field. So your Q2, let me clear this. So your Q2 will be 2 coulombs divided by 2 meters squared times 4 meters squared. Okay? And so, of course, that's the magnitude of Q2. And that turns out to be what? Four squared is 16. 2 squared is 16 over 4 is 4. 4 times 2 is 8. So the magnitude is 8